Hello everyone and welcome to another stream. It has been about a week and a half since I streamed that last video with the Shunting-Yard algorithm, and today we're going to be starting a project that will be putting that algorithm to use. So as you can tell by the title, we'll be creating a graphing calculator. We'll be doing it in HTML and JavaScript. So what we'll be doing in this video is we'll be creating our GitHub Pages website, which is just a way to host a static website for free through a GitHub repository. And then we'll be adding our Shunting-Yard algorithm, and then we'll be adding a canvas and all that stuff to actually display the graph. So the first thing we want to do is, once we get into the browser, go ahead and head over to github.com. And this isn't necessary. I'm just going to do this step just to show you guys how to create a site, but you don't have to do this if you don't want to. So I'm going to go ahead and say new repository. I'm going to say yt-graphingcalc. You can add a README if you want, and I'm just going to go ahead and create a repository. So once this creates, this is what you'll see, and I'm going to go ahead and I'm going to create a file. I'm going to name it index.html, and all I'm going to put on it right now is just hello world. I can't type today. Alright. So create index.html. Commit new file. And if you don't know what GitHub is, this isn't really much of a GitHub tutorial, but I just use this to store all my code. So now, once we have that index.html file created, once we actually activate GitHub Pages, it will look for that index.html file, and that's what it will display. So go into the settings page of your repository and scroll down to GitHub Pages, click on source and go to master, and then it'll reload. You can go to code. Check out, it's ready to be published. So if you go to this one, it'll show that it's not found because it has not deployed yet. Alright, so one environment, you can see here in this page right here that it deployed GitHub Pages, so we can click view the deployment, and we'll see our index.html file. You see the body, it's just hello world, just like that. Okay, so now that we have that created, we can go ahead, clone this repository to our computer. So I'm going to go to GitHub desktop. You can do this in a bunch of ways, but I'm just going to do desktop for now. I'm going to go ahead and clone repository, go to yt-graphingcalc, and I'm going to clone. Alright, so now once you have cloned it, you have full editing access to your website. So once you make any edits to the website, if you add files, you add code, I sound like I was from Michigan there, code. If you add anything, you make a change, push it to GitHub, and the site will deploy again once you commit. It's pretty cool. So, all right, so here we can just open in Visual Studio Code. Alright, and this is what we have, and this is our index.html file that we just created. And now we're actually going to download the file from last video. So we have main.js, which is our Shunting-Yard algorithm. This link will be, or the link to this folder will be in the description of the video. Hold on. So once you get to the folder, just go ahead and open up main.js and then click raw, and then right click and save as, and I'm going to name it shunting-yard.js, and I'm going to locate where I cloned my website to, so that's over here, and I'm just going to save it there. So now once we go back into our folder, we can see that we have the Shunting-Yard algorithm that we constructed last time. So now we can also, if you want, just copy the code from our index.html file in that same folder. I'll just do that for now, just because I want to add something before we actually start testing the graph. All right, so just go ahead and put what we have for now in here. And we can commit this just to test out the website. So added, what was it? Existing Shunting-Yard Algorithm. And testing on GitHub Pages is not the best. Well, I mean, it's close to real time, but it's not real time. So I recommend that if you're on Visual Studio Code or some other text editor like this that has plugins, you should get a live server that will update. It hosts HTML pages on a local server, and every time you save a change, it'll update. So I have one. What's it called? It is called. Hold on. Where is it? It's literally called Live Server by Ritwick Day. So if we go live, you'll see this is exactly what we had last time. So if I go ahead and evaluate it, oh fuck, something happened. What happened? Oh, that's right. So we have main.js in the index.html file, but we're actually looking for shunting-yard.js. All right. So in the script file, just do replace the main.js with shunting-yard.js, and you'll see now it reloads, doesn't have any problems, and we can click evaluate, and we'll get essentially 0, which is what we want. I can actually remove those print statements just because we don't need them right now. Where do we have the console.log? Let me just do a little search. All right, good. Okay, so that's pretty much how you create a GitHub Pages site, and that's also how you can begin to test it. Okay. Shit. Okay, so now that we have all this code imported, we want to. Well, the end goal of this project is create something that looks. I have the file somewhere. Is it file? C. I found it. It looks something like this. So you input a function, do a little bit of that, and you got a full graphing calculator at your disposal right here. But the end goal is something like this, is obviously with ticks and stuff to identify scales, but this is what it looks like for now, and I'm hoping to get somewhere like this by the end of this video. So we'll see though. Alright, so the first thing I'm going to do is I'm going to add something. Hold on, I need to. Oh, because I have this tested elsewhere and I don't want to screw it up. See, I've learned my lesson with the with the password vault project. That was the largest shit show ever. I came unprepared every single time, and I ran into problems every single stupid time with packages, and I just gave up. I would like to gut React Native, but it's a great thing because I don't freaking know. I need to take a break from mobile development. It's annoying, but hold on. Come on, open up. Anyway, I hope your Friday morning is going well. I am off of school until, well, I don't have class until 12 or 1:35, so got about 2 more hours in this stream until I want to go make some lunch. But yeah, we'll see how far we can get there. Let me see. All right, so here we are. Okay, so okay. So under constants, we're going to create another class that we'll have to identify separately in our algorithm, that it's going to be called variables, because as you can see in this site right here, I'm using X. But if I were to put that in our existing one, invalid input, because X is not defined as a constant as anything. So the way we're going to do this is we're just going to add another classification. It's going to be something like the constants. So all I'm going to do is I'm going to do let var names equal, and then I'm just going to type in all the variable names. So it'll be the letters A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. Hold on. Did I just go back to elementary school? Or no, preschool, sorry. And then you can do the, you see, hold on. How does GH? And then you can do the uppercase ones if you want as well. I actually meant to do something with the functions. I meant to add them, but I never did. Yeah, we can do. I'll take care of that later. But so that's the variable names, and that'll be something like that'll be the equivalent of this constant names. But the thing is, it's easier to convert those 52 letters into a dictionary rather than create a dictionary with 52 entries separately and define them. So the way we'll do this is we'll have an empty dictionary, so let variables equal an empty dictionary right now, and then we're going to iterate through the var names and assign 0 to the starting value. So for var I is equal to 0, len is equal to var names.length, I is less than len, I plus plus. So variables at var names.char at, and it'll be I, so we're just getting the ith character, I, and then we're just going to set it to 0 as a default value. Okay, so that'll be our variables, and then once we hold on. Let's see. Hold on. So what we have all the this variable dictionary will now be initialized with the 52 entries with each of these letters as the key and 0 as the initial value. So like I said before, it's going to be another classification. So we need to add one function just to test if it's a variable. So function is variable, and we're going to pass in a C like the other functions, and then we're just going to return object.keys, and it'll be variables, or actually we can just say return var names dot includes, includes C, just like that. So if we pass in, let's say X, it'll return X, like that. All right. Let me just check if I have anything else. All right. All right, so now we're going to go into our RPN method, because this is going to be another classification. So it's going to be a different type of token, because we can't treat it like a number, because the variable it can be different every time. So we could pass in a different, we can change that variable in every iteration. So if we were doing a graph, we would iterate through from 1 to 500 or whatever, and that X would change every time. So we can't just get a constant number. The variable will be changing, so we can't pass in the current number value for X, because then it won't store the equation in a tree containing those variables. So in a second conditional statement, do else if, and then in parentheses is variable t. So we're using that function that we just created, and we're just going to go ahead and say type is equal to type const, and object is equal to t. So we're gonna kind of treat it like a constant, but only in the manner that we're gonna pass it through the algorithm like it's a constant. So we're gonna treat it like with that demonstration where the numbers were just pushed straight through, that's the same thing is going to happen with the variable. So, all right, I'm already losing my freaking, goddamn, my mouth is getting too dry. I don't know how. Okay. So like I said, this, we won't have to modify this at all, because when we get a variable in the stack or in the string iteration, we push it straight through to the queue and it'll work properly. But the difference is now comes with, hold on, I think I'm gonna have to add something to, well, let's see. I think that this is variable is not very, I don't know, it's not too useful, because the only place we'd be using it is there. But we can also just add it to isNumber, because like I said, we're going to be, alright, I think I'm contradicting myself. I originally said that we weren't going to be treating it like a constant, but that's only in the evaluation, in the parsing to a tree. But when we put it into reverse Polish notation, we're going to be treating it like a constant. So in isNumber, we're just going to say, wait a minute, might have to, no, this is fine. So in the isNumber, just add it at the end of that return statement, or var names dot includes t, like so. So that'll just return a number. So if we pass in a variable name, it'll just return that as true. So we just have to modify, get rid of that conditional statement that we just wrote, just because it's useless at this point. So everything else is treated properly, the same. It'll do that. So when we get into the parse to a tree, it'll treat it like a number. It'll give it'll give the variable its own node, and because it's a constant, it won't have any children, or because it has a numerical value, it won't have any children with it, which is good. And then evaluate tree, blah blah. All right, so now in the evaluate, this is where we're gonna have to add another line. So it's not going to be a function. So in the else body of the evaluate function, add in a second conditional. So after the if statement, do, wait a minute. Okay. So after the constants, we're going to say else if, and then var names dot includes tree dot val. So this is just testing to see if the token is a variable, and if it is, we're going to return variables at tree.val. Okay, so now that we have this updated, what we should get when we multiply this by x, because remember we set everything to 0, we should get, hold on, t is not defined, is number, oh yes, make sure you put a C and not a T in isNumber. That's my fault, my mistake. Alright, so if we put a times X here, we should get a 0. NaN. Is that, hold on. That, wait a minute, this isn't working right. Hold on, let me reload this. Wait, fuck. Uh-oh. Something's wrong. Oh my, we do, so I was right the first time. The reason why it's giving that is because it sees this S and treats it as a variable, because S is a variable. S is a variable name. So we do need that is variable at the end. So function is variable C return var names dot includes C. There's a emergency vehicle going by my house right now. Ambulance. All right. So yeah, that was my mistake. Okay. Yeah. So it's not really a. Well, I guess I could just put in the so once we added that function back, go into RPN and just add is variables. Wait, no. Wait, no. Add that conditional statement that we had it before. So else if is variable t. Like so. Alright. And then just do the so type is equal to type const and object is equal to t. So now this should theoretically work. So evaluate shit. What happened? 265. Oh, yeah. So now when we go into parse, we have to generate a special type of node for a variable. So else if, or actually, I'm sorry, I'm all over the place. Let me type in this code and then I'll explain everything from the start. So or is variable t. So what we did so far was we added, let me just make sure this all works. Alright, 0, good. Alright, so what we did was we added variable capabilities. So we just added this dictionary that has every variable default set to 0. And now we just added this is variable just to test if it's in there. And in the reverse Polish notation, we tested to see if something was a variable, and then we passed it in and treated it like a constant only in here though. And then in the parse method, we just treated the variable like a number here, and we just generated the same node. But in the evaluate method, we had to distinguish between constants, numbers, and now variables. So in the first stream with this algorithm, we tested if constant names dot include. So if it was in the constants, so that's pi and the natural base e. And then we also just had numbers. That was like 15, 8, stuff like that. And then we just added this condition to see if the variable names included the token. And if it did, we just returned that value, the current value of that variable at that time. So this should work if I do something like 3 times 0, or 3 times x should get a 0. Because remember, default, they're all set to 0. Okay, good. So that is our variables now. How long have we, Oh, you know what I never did? I didn't even put the music on. I wanted to put some music on. Let's see. Let's put some nice calming music on. That was kind of crappy, my explanation. I'm sorry for that, but hopefully you guys got through that. And once again, if you don't understand it now, this will all be pushed to GitHub by the end of the stream. And yeah, okay. So now let's get to creating our actual graph. So if we want something like this, we're going to use an HTML element called a canvas. And the reason why is because we can actually draw lines with this canvas. We can do all that sort of shit. Alright, so in our index.html file, or in our folder, I should say, we're going to create a new file called draw.js. And we're going to include it after the Shunting-Yard algorithm. So at the end, just do script source is equal to draw.js. And because the Shunting-Yard algorithm is now only designated it's only going to be designated toward the actual algorithm, we can get rid of this, the buttons. So with that, or actually buttons, and paste in the onto the canvas. So put that there, and now we're going to be adding our canvas. So just literally called canvas. I'm going to do ID is equal to canvas, width is equal to 750, and height is equal to 750. I should probably put that in quotes. It's my first day on the job. 750 like that. Hold on, did I don't think I'm sorry. I took it off the warming up screen. I feel awful. Alright, so all I did was created a draw.js file in the folder and transferred this button listener to that file from the Shunting-Yard file, and I included the draw.js file after the Shunting-Yard. And then I added this canvas here with an ID canvas with the 750 and height of 750. Alright, so once we do this, I need to open up I completely forgot where I got started with this when I was testing it, so hold on. Okay, so and then we just need to add a single style statement to this. So style is equal to border 1px solid blue, just so we can see the bounds, and then box sizing is just going to be content box, just like that for now. Because there is a margin that is associated with the canvas, and it gets kind of annoying to deal with that when we're getting positions of stuff. Alright. So in the draw.js file, at the top of the file, we're going to get the different elements. So var in element is equal to document.querySelector hashtag input. This is going to be the input text box. We'll need the out element is equal to document.querySelector hashtag output. That'll just be where we can output what we're graphing at the point. And then var btn is equal to document.querySelector hashtag btn. Not bts, don't worry. And then btn.add event listener right there. Alright, so now we also want to get the canvas, so we're going to do var canvas is equal to document.querySelector hashtag canvas. That was the ID that we assigned to the canvas. And hold on, let me just make sure. Alright, so with canvases, there's something called the context, and if you have prior experience with graphics and something like JavaX or Java.swing, this will seem a bit familiar, but if this is your first time, canvases have something called the context, and that's just essentially how we can draw on it. So var ctx is equal to canvas.getContext, and it is 2D, not created 2D. Alright, and then we'll also need the bounding rectangle. So var rect of the is equal to canvas.getBoundingClientRect. That'll just be a that'll be important later on. Alright, so what we can now do is we'll need just a function to update this rect, because it might not be the same every time. So this will be something that we have to take into account. Oh, this song is fucking, it's just called Death. It's literally called Death. And he just fucking yeets a chicken. I noted this the last time I heard this on stream. Just freaking smacks a chicken in the face. Alright, so we'll create a function. Yeah, this is too loud. Function, and then it's going to be update rect, and we have to pass an E. E is not the Markiplier thing. It is the event that is associated with a mouse click, mouse drag, mouse scroll, stuff like that, because we'll be needing those events to do the drag, scroll, stuff like that, the click. So we'll need to pass an E there. All right. So I'll also need some other things right here. So var width, var height, var cursor x, var cursor y. Alright, so width is equal to, or actually, rect is equal to canvas.getBoundingClientRect, because it might change. Because this function doesn't update every time size changes. We set that in the beginning, and it gets the initial bounding client rectangle. So we want to update it every time we get an input. We'll do width is equal to rect.width, height is equal to rect.height. Hold on, I need to we'll also need a left and bottom. So var left and var bottom. We can actually get rid of that initial call, because we'll just call the function all at once. So left is equal to rect.width, or left bottom is equal to rect.bottom. Cursor x is equal to e.cursor, or client, actually client x. Cursor y is equal to e.client y. Sometimes I get rude and just start spewing out code, and it gets difficult. So this movie is slow down, which is nice. Alright. So what we're going to do now is we're going to create two more variables called LastX, X, and LastY. This will be important for the drag and drop. Because, for example, if I start here and I drag it like that, I want to get the distance that I dragged it, and then I'll move it that distance. So we'll need the LastX and the LastY. Okay, but we don't want to just drag it every time we move the mouse across. So before we do that, we'll need to get a Boolean variable to test if the mouse is down. So that'll be another variable called MouseDown. And we'll do something called, we'll add a listener to the canvas. So canvas, add event listener, and it's going to be MouseDown. And all it will do is just E, it'll pass in as a lambda parameter, so the event will do MouseDown, hold on, is equal to true. LastX is equal to LastX is equal to e.client x. LastY is equal to e.client y. This is so good. So the reason why we're setting these LastX and y values now is because if we drag it over here, LastX and y is going to be where my cursor is now. If I move the mouse up here and I drag it, it would, and I didn't have those lines, it would think that the LastX and LastY was still down here. So it would drag it like, it would do that drag all the way like that. We don't want it to do that, so we just wanted to update the LastX and y every time the mouse goes down. But we can't just put e.client x and y because of the different type of sizing that we have, positioning that we have with HTML elements. So we'll actually have to update our rectangle again. So UpdateRect, and then pass it LastX will be set to cursor x minus left, and LastY will be bottom minus cursor y. So let me show you what this is going to look like. So on our graph, we have the left bound of the rect. See, it's not on the left. There's a bit of padding right here. So this is going to be left, and if we have our cursor out here, which is like 400 pixels out, we want to have it as 400, but it's going to give us 410 because the cursor X is from the left side of the browser screen, not of the element. So we need to subtract the left. So we do cursor X minus that left. And with the Y, we want to do the bottom. So like I said, it's kind of weird because 0 is in the top left. 0, 0 is in the top left in all graphics. So we want to get the left, so the bottom side minus the cursor. So that distance between the bottom and the cursor is going to be our Y value in pixels. Alright. So once we have that, we can just add the second listener there that will help us, and that'll just be the mouse up. Canvas.add event listener, mouse up, and it'll just pass an E, and it'll just be mouse down is false. Because when the mouse comes up, we don't want to drag it anymore, so we'll just make that false. Okay, there's actually a couple of lines that we have to add before we do any dragging to actually do stuff with the draw function. So we want to set or align canvas properly. Not on the screen, we want to align the coordinates properly. So what we're going to do is we're going to do ctx.translate 0 canvas.height. What this is going to do is, because the 0, 0 is up here, we want to translate the 0, 0 down to the bottom left. So it's up here, and we translate it down the height. That'll make 0, 0 here. But because it's now rotated, or this is positive y here. Let me draw this out. It's hard to explain. I'll try and draw everything out actually, like all of the client X and client Y. It's annoying, but it makes sense. Okay, so the way the canvas works is, let's say this is the bounding rectangle of the canvas. That point up there, that is 0, 0. Positive x is like that, or positive y is like that, and positive x is like that. So this point over here, let's say the width and height are 500. This point is going to be 500, 500. And this point here is going to be 0, 500. And this point over here is going to be 500. So in order to get the origin on the bottom left like we want it, so we want to translate the origin down there. We also want to rotate it, because if we put the origin down there, we're gonna translate it, but the positive y will still be downward, which is not what we see in a traditional graph. So y will still be pointing down. So we want to rotate it like that, about pi radians. For all you scrubs who don't know what a radian is, in a circle we have 2 pi radians, so like that. And we have the origin. And we're starting at the x-axis. To get to the y-axis, that's pi over 2 radians. Now to get to the other x-axis, the other side of the x-axis is another 2 pi over 2 radians, so it's a full pi radians. And to get back to the start, it's just 2 pi radians total. It's just an alternative measure for degrees, and it's what the canvases use standard. So once we have it rotated, it'll look something like this. So we have these points over here. The problem is we're going to have the origin on the right side. This will be 500, 0. Because if you can see, if we rotate it by pi, it'll be like that, and it'll be kind of annoying, kind of bullshit. Or actually, the origin's going to be up here. I'm screwing up. But regardless, we're just going to have to mirror the canvas to make sure that it's aligned properly. So once after translating it, we have to rotate it. So ctx.rotate math.pi, like that. ctx.scale, and we're going to just scale it -1 in the x direction and 1 in the y direction. By putting -1, we're essentially just mirroring the canvas across. Alright, so we have that all good. So we can actually add our first graph now without actually doing any drag or drop functions. And the way we're going to do this is we're going to need an array to store equations. So we'll have var equations is equal to that, an empty array, and that will be storing trees that we parsed using the Shunting-Yard algorithm. And then we're just going to need another graphics variable called global scale. It's equal to 100, and that's just going to be the pixels per unit on. So it's going to be like pixels per one tick on the graph. All right. So we're going to add a function that allows us to draw the stuff. So we'll need function draw, and we'll pass in a tree. Draws equation on canvas. So what we're gonna have a couple things here. So we'll need an I. So far, I is equal to 0. Do I have a dx somewhere? Hold on. Hold on. Well, also, I'm very disorganized, but once we get all the code down, it'll look right. So we'll need some more graphics variables actually. So var min x and var min y, and then var dx. So the min x and min y will just be the x and y is the coordinate of the bottom left corner. So that the actual numerical coordinate when this thing is turned upright, not the pixel coordinate, the numerical coordinate. So we do that. We want to update our dx, so dx is equal to 1 divided by global scale. We'll have a y value, so var y, and then we want to set our variables, because remember variables comes from the Shunting-Yard algorithm. That's this thing right here. So this dictionary right here. So variables.x is equal to min x, like that, and we just want to say var width is equal to canvas.width, like so. The first thing we want to do is we want to check if the function is defined at min x. If you don't understand this, don't worry about it. This is just some complicated checking just to make sure that the function actually exists. Like if we had a function that was 1 divided by x, that would not be defined at 0, at x is equal to 0, because 1 divided by 0, you can't divide anything by 0. No, you can't really do much of that, can you? Okay, so we need just to test where the first defined point on the graph is. So let's do a while loop. So while, and then in parentheses, y equals value 3. That is not equal NaN. So if it was multiplied by x, it would have 0. That would be NaN. So we want to know that, and just make sure that we don't go over plus I times dx, and then I plus plus. Alright, and then we'll need, so just find first defined point on graph. Alright, and then we'll need a variable called PreviousY, like that, and this will equal y minus min y times global scale. So this will be a coordinate. So the previous y, this is now a pixel coordinate. So the y right here, that's the value we get from the evaluate tree. That's the first defined point. And then we essentially get the distance from the minimum of the graph and multiply it by the global scale to get the number of pixels it is from the minimum of the graph, from the bottom of the graph. And now we can get into our iteration. So for, we'll have an empty first clause, because I is already set to something. I must be less than width, and I plus plus. Like that. We'll do something similar to that while loop up there. So variables.x is equal to min x plus I times dx. Y is equal to evaluate tree. If y is equal to NaN, we want to go ahead and continue. Wait, actually, hold on. If we continue, that'll do nothing for us. Oh, wait. We'll have to copy this while loop because we detected. Hold on. We just copy this while loop right here. Detect discontinuities like that. So that should help a little. All right. So if we run into a discontinuity or a point where the function is not defined, we'll just find the next one. Hold on, I need to. And we'll do the same thing. So y is equal to y minus min y times global scale. hold on. I think I'm screwing up somehow. So we set x initially in the for loop in each iteration, and then we find the first defined value. So if it is, so let's say it is defined, we just want to go to and set the one and one. Wait. So here we get the evaluation of y, like the number value of y, and then we essentially want to convert it to a pixel coordinate. So we have that there. That's fine. And then we're going to draw out. Yeah, this makes sense. Evaluation. So y is equal to the value if we found a point where the function is not defined, we don't want to draw anything because in a graph like, let me actually go into Desmos quickly just to demonstrate. Start graphing. So if we had something like tangent of x, like that, you see that the function is not defined at this value here, which happens to be pi. Wait, not pi, pi over 2. So the function is not defined at pi over 2. When we cross pi over 2, we're not going to get it. We're going to get an NaN as our value for if we had tangent x as our function. So the previous y would be infinity at all the way up there, infinity, and it would draw a line straight down to negative infinity. It would draw a line from up here all the way down there, and we don't want that. So we just want, if we find discontinuity, don't draw anything. Just set the previous y and go to the next one. I think that makes sense. It should make sense. I hope that works. Alright, so once we go into draw the line, we want to say ctx.beginPath. This is how you draw a line. So ctx.beginPath, ctx.move2. We want to go I minus 1, previous y, like that, because I is a pixel coordinate. I is the x pixel coordinate. So we want to go to the previous one to start the path, and ctx.move2, I, y, that'll be the current coordinate. So if you can tell, we're going to be drawing a line segment for every little distance, every dx in there, essentially. And then ctx.line2, I, y, ctx.line_width is equal to 2, and ctx.stroke. Don't take that wrong. Don't take that as a joke. It's a stroke, like a paint stroke, not a different type of stroke. But I don't know. I don't know what you guys are thinking. But all right. So previous y, and just set the previous y to y. Okay. Okay, so that should be good for our draw method. And now what we want to do is we're going to change our button listener. So alright, so button. So when the button is clicked, we want to get the value. So we can actually just replace this with inElement.value. RPN is the same thing. Val is equal to invalid input for now. Or hold on. We're going to say out is equal to invalid input. So if RPN, we want to get the tree by parsing the reverse Polish notation. We want to add the tree to the equations array. So we'll pass in a dictionary with the equation is just the equation value. That'll be helpful later. And then tree. So we're giving the name of the equation and the actual tree into the equations array. And then we just want to go ahead and draw the tree. And then out is equal to, we're going to string interpolate, graphing y is equal to the equation in curly braces like that. And then we can just change this query selector to out elements. And that should be good for now, I'm hoping. 2 times x. Because val is not a val. Wait a minute. Wait. Hold on. I did something wrong. We don't want the val. We want draw. Wait, no. We want it to be out. I'm really stupid. 2 times x. Fuck. Alright, I think that's... something's not right. We just go to the draw and see. I never did. Min x, alright, is equal to 0. Min y is equal to 0. Great. Don't worry, guys. I got this. Don't worry. It's not working. Oh, we're skipping this. Where's the music? I cannot. 13 sucks. 13 is. Oh, shit. Alright, console.log. evaluate tree. Let's see. So in evaluate, I'm just going to go ahead and console.tree.val variables x0. Why is it? Oh, I'm really stupid. I was putting a capital X, like a dummy. But it's still not drawing anything. Which is weird. I can get rid of the console.log since I know that's broken. I don't think it's getting any discontinuities though. Let me just see console I1. Yeah, that looks right. I don't know what's IY, but it's not drawing. Unless I translated it incorrectly. But I thought... Hold on, how do I... Let me... Wait a minute. Oh, because I... Oh, fucking bitch. Because I say move to, I'm a really stupid idiot. I said move to the coordinate where you have to draw it to. There we go. That's good. That's perfect. That's exactly what we want. Fuck! It's shit like that that just catches you off guard. Just, god fucking damn it. It's dumb shit like that. So the reason why I wasn't drawing was because I moved to the previous coordinate, but then I moved the cursor to the current coordinate, and I drew to the current coordinate, so it didn't draw anything. That's just wonderful. I forget. I'll probably remember it at some point. Okay. So now that we have the drawing function down after however long, so we're going to add a section for the drawing functions. Like that. We'll need to draw axes as well. Function draw axes. Alright, so now I'm going to go ahead and I'm going to get into OneNote once again. I'm going to draw some stuff for you boys. Hold on to your panties. This is the... See, I'm a... Where's my cursor? Alright. Is it... There we go. Something's not working. There we go. Alright, so if we have our graph like this, and we have a, let's say min x is equal to -3 to the global scale is equal to 100, So that means 100 pixels per unit. So if our width is, I'm just going to make it 800 for simplicity. If our width is 800 and the global scale is 100, that means that there will be 8 units on the graph. So -3, 2, and this will go all the way to 5, 10. All right. So the axes that will be drawn is the x-axis. The x-axis will be drawn on this graph because -3 and 5 they change a sign. Well, this is, I'm pretty sure this is a disk, isn't it? Cat? Yes, a disk. It's so good. Hold on, wait for the drop. There you go. That was the great drop. I'm only kidding. This music is fucking amazing. Okay. So we essentially want to test to see if min x. So the way when we would draw the y-axis is when min x is greater than -5, and it's also less than or greater than -8. Because if this is -8, it's still going to draw it on the right side. If it's a +8, it'll draw it on the left side. So we want to test to see if it's greater than -8 and less than 8. So the way we'll do this is in the draw. If min x is greater than or equal to -canvas.width, wait a minute. Yeah, so if it's greater than, because we want to get a negative value here, so -canvas.width divided by global scale. So a little bit of dimensional analysis here. Canvas.width is in pixels, global.scale is in pixels per unit. So a pixels divided by a pixels divided by a unit is just a unit. So we'll be getting units, the amount of numbers that are in the stupid thing, in the canvas. And it has to be less than, so min is less than or equal to the positive side of that, so canvas.width divided by global scale. And we're going to draw the y-axis in this case. We'll do ctx.path. ctx.move. Now, what we're going to do is, so to draw the y-axis, we want to do I'm looking at my code right here. I've written before. Alright, so this distance right here, this is too glitchy. I can't fucking... Oh, where did the graph go? Draw, not to select. Oh, it's over here. Alright, so this point, oh shit. This point right over here, we're doing 0, 2, right? Just because that's the y-axis, and the x value of the y-axis is 0. So it's going to be 2 units over, like that. And the number of pixels this will be is going to be 3, or 3 times global scale. So the way we can look at that is we'll do a min x times global scale. But it will have to be times -1. Just because that will give us a -300 we don't want. So we'll say ctx.move to map.absolute value, because if it's positive, we'll be making a negative 5 this time, and we'll do ctx.stroke. So let's see if this works out. We should see. I don't actually call the function, so hold on. Yeah, so you see the y-axis is right there. That's exactly what we want, and it'll be pretty similar for the x-axis, except we'll be dealing with the min y and min x. So min y instead of min x. So if let's get my tablet out of the way. So if min y is greater than or equal to negative canvas.height this time divided by global scale, and min is less than or equal to canvas.height divided by global scale. It's essentially the same exact thing as this, except we'll need to test to see if the minimum y is negative and the max y is positive. So it's essentially the same logic. So we'll draw the x-axis, the ctx.begin path, ctx.move to math.abs min x times global scale 0. Wait, no, hold on. I was copying the line. 0, comma, math.abs min y times global scale. Brackets. Wait a minute, what just happened? And then ctx.line to we'll do 0, or actually this time it's going to be canvas.width, and it'll be math.abs min y times global scale. And you can see to draw. Wait, and I never draw it. Computer. Alright, I never drew it. ctx.line width 0 to 5, ctx.stroke. And there it is. And you can and I'm going to test to see, let's say min x is equal to -1 and min y is equal to -2. You see the axes are right there. But if min x is 3, hold on. Did I screw something up? I think, wait, no, I don't think I can do the math.absolute value. It has to be a negative. Wait a minute. Yeah, it has to be a negative. I don't know why, but it does. That's what worked for me last time. I think it's because I'm giving it a 2 times the width thing. So like it could be anywhere. Hold on. Yeah, it could be anywhere in between -800 and 800, or min x, because I'm giving it 2 times the width. So this gives it a 2 times the width range, so it has to be negative there. And you see like that. That is what we want. Because this goes from 3 to 11, like that, and that doesn't give us the axis at all. And if I were to graph this. Did I do it right? Let me go back to 0, 0, just to make sure I didn't screw anything up. Okay, that's right. Next, 1, 2. Okay, good. Now let me try min x at 0. Axes function. We can go ahead and get into our motion functions. So we have the mouse up and mouse down, but that was pretty simple. I was just getting values, but now we're gonna get into the mouse move, where we actually have to translate, or not translate everything, just move min x and min y. All right. So we'll need a couple. We'll need a couple of functions first. So at the bottom, under the draw axes, we'll need a function called clear canvas, and it'll be ctx.clearRect 0, 0 canvas.width canvas.height. That's just clearing the entire thing. Function redraw that takes in, and then that'll call clear canvas. It'll call draw axes, and it'll draw each equation in the array. So array.from equations dot for each, and for every equation we want to do draw the equation.tree, and then we just want to reset. So function reset equations is equal to that, nothing, and then just clear canvas. Alright, as simple as that. And now we can get into the listeners. This should be wrapping it up relatively soon. Yeah, and then once we get through this, I think we should be done for the day, actually. Listen. I'm just going to add some comments here. So we'll need a couple of things. So we'll need a mouse move. So canvas.add event listener, mouse move, and we'll be passing an E. And when we don't want to change anything with the mouse move, well, we don't want to change anything when the mouse moves if the mouse is not held down. So if we're just dragging the cursor through it, we don't want anything to move, but we only want to move it when the mouse actually held down. So we'll say if not mouse down, just return. And otherwise, we want to update our rect. So also add something to the UpdateRect. So for cursor x val, that will be like the pixel x coordinate of cursor in pixels, y coordinate of cursor in pixels, x value of cursor, and we'll do the same thing for y val of cursor. Alright, so what we're going to do here is we'll just say cursor x val is equal to cursor x minus left. We see when we do this, we can cursor y val is equal to cursor with bottom. I can type bottom minus cursor y. Shit! I made the whole mistake. I need to gather myself. I just started this right. And then we can replace these computations here with the LastX and LastY because they're the same. Make sure you spell everything right, because otherwise you screw up. I did that. That's not variables are defined here. Let's go. Alright, so on mouse move, we want to update the rectangle. So now we have cursor X, cursor Y, all that good stuff. We want to do, so we want to translate graph, min X and min Y. So the way we'll be doing this is, we'll get a dx. Yeah, so var, and this is a different dx. The dx that we used in draw, that was the increment between points. This dx is just going to be the change, like delta x. So it's equal to cursor x val, yeah, minus last x, and then var dy is equal to cursor y val minus last y. God damn it! And then min x minus equals dx, min y minus equals dx or dy. Son of a bitch! Fuck! What is going on? I don't want dynamic compressor mode. Oh, I didn't put the underscore. And then LastX is equal to cursor x val last y is equal to cursor y val, and then redraw this whole thing. So that should actually be good enough for our, let's test this out. I don't think that worked. Let's add a little line just to test something. Out element dot inner HTML is equal to a string interpolation, and we just want the coordinates. Hold on, is last x and last y, are those a curse? You know, last x and last y, those can just be the cursor values, like not the coordinate values. Cursor x, min x minus equals dx now divided by global scale, just to get it back in units, in the proper units, global scale, and it'll just be cursor x and cursor y instead of the values. And this should work. Hold on. I want to do min x plus cursor x divided by global scale, and min y plus cursor y divided by global scale, just to get the current value of the cursor. We can actually do this up top. Is it not? Is mouse? Hold on. Mouse down. Oh, I just need to update these. Wait. Fuck. Hold on, it's just not. It's not reading it right. Canvas. Oh, because I didn't put the E. Fuck! Shit. I cannot type for my fucking life today. At least we got something. Shit. UpdateRect, I never pass an E. Great. Wonderful. Wait a minute. Ah. Problem is it's going negative. Did I miss out a negative sign somewhere? Minus. I think because it's going opposite. So let me try doing a plus equals here, real quick. There we go. Okay, it's working. Let's go. It's not that smooth, but it's working. We can get rid of that console.log right there. Alright, so we have the mouse move working. Let's go! Oh, fuck! 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 Ah, that was so shitty that I just didn't type the E in. E. Fuck. Okay. And now for the last function, we'll be doing a scroll event. So I'm going to do a little bit of a draw here. So mouse move. For some reason I keep missing the E. Why? Scroll for zoom. All right. So canvas.add event listener wheel E. I want to get var dy is equal to negative e dot delta y. That's just the scroll wheel. Delta y, I don't know why it's like that, but delta y gives you the scroll wheel. Hold on. Is this, I don't know if, hold on. I think I'm fucking something up here. No, it's fine. Don't worry. We're all good. We're all good. Alright. So in the wheel, we want to get a var x is equal to min x plus, because we want to get the x and y value of the stupid thing of the cursor, like in the coordinates, not the pixels. And y plus cursor y divided by global scale. I'm just going to do the same thing here. Copy this. It'll just to get cursor position. I don't think that matters actually. No, it doesn't. We don't need that. Alright, so if dy is greater than 0, and I just negated that there just because if you scroll up, it's negative. If you scroll down, it's positive. Don't know why, but don't ask me. Alright, so we're going to scale up. And else, if dy is less than 0, we want to scroll or scale down. And then at the end, we will redraw, like so. I also want, or no, that's fine. Okay, so I'm going to do a bit of drawing quickly here. Alright, so in our base thing, in our base graph, we have, let me just scroll down a bit. So I'm going to use S as the global scale. So S is equal to global scale. And let's say, so S, if S is equal to 100, we have our graph here. It's not to scale, and just leave them like it is. So this is at pixels 100, 100. This min x and min y is at, let's say, -1 and -1, like that. So if our scale is 100, that means that there will be 100 pixels per unit. So that we can translate this into 0, 0. The reason how we did that was we get x is equal to the minimum x value plus the cursor value times the scale. So cursor, or actually divide by scale. And the same thing for y. So y is equal to min y plus cursor y divided by scale. And we wrote that out. So this distance is 100 pixels. and this distance is 100 pixels. If we now scroll, oh shit, I dropped one of them. All right. If we scroll up, so if we scroll up, let's say we make S 105, okay? The coordinate will stay the same. The pixel coordinate will still be 100, 100. And the trick is we're gonna be scaling it around this coordinate here. So 100, 100 will stay the same. This coordinate will stay the same. So it'll still be 0, 0. The difference is now min x and min y will change. So we have now the distance is still 100, 100. But because the scale is 105 pixels per unit, this is going to represent 0 minus 100 over 105 and 0 minus 100 over 105. So the reason why we're doing this is because we're centering it around, or we're scaling it around this the current coordinate of the cursor, and we're going to be doing it to the scale of 100 over 105. I hope that makes a little bit of sense. Yeah, I hope that makes sense. So this will now be whatever negative that is. But the point is, this coordinate right here will be different than this coordinate right here. So the 105 is going to be accurate because in our scale up, we're going to be multiplying the scale by 1.05. So global scale times equals 1.05. And then in the scale down, we want to subtract or divide by, or multiply by 0.95. So global scale times equals 0.95. And now we have to update min x and min y. So update min x, min y. And once again, this would work the same in the other way, where we would just subtract, if the scale was now 95, this coordinate would be further away from 0, 0. It would be negative 1.05 or whatever. Negative 1.05. So min x is equal to x minus cursor x divided by global scale, and min y is equal to y minus cursor y divided by global scale. Alright. But the point is, the pixel distance does not change. So we had to convert it to our values in order to determine the change. So let's say we graphed a little x squared minus 6x plus 2. Let's evaluate that. Hold on, cursor x not defined. Isn't it? What? How is it not? Isn't cursor x what? Or I guess I can just call UpdateRect. Alright, yeah, I'll just do that. Alright, so this fuck. Client x of undefined. Oh, I'm let's see. This function is getting kind of annoying, but I do want to keep it there just because it has to. If something changes, we have to have that. But I guess I can get rid of this stuff here. Yeah. Yeah. All right. So here we'll do. So we'll copy cursor x and cursor y. Put that in mouse down. Put that in mouse move at the top. And put that in wheel. So put that in all three. And I don't think we need the cursor x val or cursor y val at all, actually. Alright, so let's do the x squared minus 6 times x plus 2. Evaluate. Alright, so that's good. Drag, nice. Oh. It was doing a little thing there. I don't know what. Fuck. Cursor X not defined. 106. Oh, did I fucking misspell it? 106. Cuss roar. Fuck. Bitch. So that function was fine. So just put that. Take that shit back to the lab. Fuck. Are you... I cannot believe it was... So... My typing is not good today. I don't know why. It's been deteriorating. Like... Fuck. Oh. Cannot read client X of undefined. Yeah, I know. Fuck. Hold on. Alright, hold on. Don't change anything right now. Don't change anything. Alright, so your new UpdateRect, let me just see this. Once this works, I'll go over it. Ah, okay, it is working. Nice. That should not be the Y coordinate. I guess I just have to negate it, but let's see. X squared minus 6 times X plus 2. Like that. Nice. Scroll in and perfect. Okay. I just have to negate that Y value, but that's fine. Alright. So what I did was I removed the E parameter from UpdateRect. I removed the setting of the... Oh shit. It finished. Hold on. Sorry. I'm off track yet again. Beta. Hold on. Alright, that's fine. Alright, so I removed the updating of the cursor positions in UpdateRect because that was unnecessary and annoying. What I did was I got cursor X and cursor Y in each individual method from the E parameter that we get. Oh, just holding my pen. I was losing my fucking mind. Oh, shit. Alright, so for the E parameter that we get in each event, and then I computed the values there, and all that is done, and it works beautifully. This all works beautifully. Another event. But everything works. That's all that matters. I just found the problem with this where when I exit the canvas when my mouse is still down and I come back in, it's still dragging. So I just have to say what is it? MDN events mouse exit. I think that's an event. Mouse leave. Okay. We can actually just put a space here. So mouse leave like that. So canvas.add event listener. Whenever the mouse comes up or the mouse leaves, just say MouseDown is false, and that should help us. Yep. No. What's going on? Something's wrong. Nope. I guess we can just do a little bit of an array action. So mouse up, mouse leave, dot for each event, and we want to do canvas.add event listener for What is going on? X squared? Yeah, and then tan x. Okay, it's not. Something's wrong with the tangent function. Something is wrong with the tangent function. But I put the proper evaluation. I'm going to try doing the cosine. Oh! What's the stupid problem? It has to be something with the discontinuity to teach it like that. It must be faulted or something. Because divided by 2, and I should get a 1. What the fuck is going on? RPN A plus 2. I guess no, I definitely 1, 2, 3, 1, 2. Oh, I son of a bitch! I didn't close my quotes. 7. Is it not doing it properly? No, the drawing should be evaluate So I got the equation, I got the RPM. Now, it's working for everything but the trigonometric functions. Zero. That's not right. Something's wrong. Sine of pi divided by 2. 1. Has to be something with the variables then. Var names dotting. Alright, so console.log tree.val. Or actually, let's just make sure it's not x, just so I don't go fucking crazy. So if x is not equal, or is not x, console.log tree.val variables at tree.val. Alright, so let's try this. A plus 5. That gives us a line of 5. Even though that coordinate is extremely wrong. But that coordinate doesn't matter. Oh, because I'm doing... I know why. I don't really care, to be honest. Alright. So, A5. Sine of pi divided by 2. I0. Let me reload and see what the line is. Sine pi divided by 2. It's giving me a 0 again. Oh, it's getting I. Hold on. Oh, I need to detect for constants first. Hold on, this is not good. Hold the phone. Let me just, alright. So in our Shunting-Yard algorithm, let me move else is variable. Hold, wait, fuck. Wait, no, I still think it's fucked up. I still think this, yeah, I fucked it up. The functions are screwed up. Okay. So in Shunting-Yard, put that else if is variable over to, hold on, is that right though? To, after if found, wait, after the constant detection. Because it was detecting the pi. Oh, yeah, I got it. Alright, it was detecting the pi, the p and the I separately as a constant. So, now this should work. Alright. Sine x. Yes! Alright, sine x works. Beautiful. Alright, it's all good. Tangent x. And, okay, yeah, so this was the line I was talking about. Obviously, the detection I had didn't work, but that is expected because pi is irrational. So any kind of bullshit there would, if you try to, I'm gonna have to add some, like, advanced detection of that shit, but that would not be fun. Regardless, that is pretty much it. Like, that's pretty much, that's the graphic. It's pretty fun. Graphical, 33 seconds ago. Alright, view deployment. Nice, nice. So that's pretty much it, to be honest. Like, that was the project. That was the meat of it. We can style it next time. Next time we'll add tick markers, shit like that. But I do want to say something. After this project, I'm planning on making or streaming a project where we create a GitHub Pages site and we have a client application on the computer that allows you to upload stuff to that site without having to like push it to GitHub yourself. So yeah, that'll be something to look forward to. But my baseball season is starting soon. So like after February 21st, the week of President's Day, after that break, baseball starts full-fledged. So if I'll probably put everything on hold at that point, I might be able to upload a video every once in a while because I'm off Sunday, so I might do something then, but not too likely because I still have school to worry about. But we'll see. This is, yeah. I will, interesting stream. And, yeah, I'll see you guys. Hold on, let me, I will, see you guys whenever, frick. Is my phone this stupid? I'll see you guys whenever next time I, go online, which might be tomorrow? Probably not. I doubt it. But whenever that comes, might be sometime. Who knows? Alright. See you guys. Bye.